What's up, everybody? We've been factoring, and we've been factoring really great problems that look like this, but they maybe don't have the equals 0 at the end. And so we're going to take the next step to solving these x squared problems. All these x squared problems are called quadratics. So we're going to take that to the next step. We're going to learn how we can solve these, and we're going to use factoring. We're going to use the same stuff that we've been doing so far. So the box method seems to be a pretty popular method to visualize it. So we can set up 2x squared in any corner, and then the -4 in the opposite corner. And the key to factoring is multiplying. Remember that factoring a number like 20 really means 1 times 20 or 2 times 10. It's multiplying. So we want to multiply the diagonal, which is 2 times -4 gives us -8. It's really -8x squared, but we're focusing on the -8, and ways you can factor -8 would be -1 times 8, or switch it, -8 times 1. -2 times 4, or -4 times 2. So we have all the ways that we could possibly factor it, and what we're looking for is -7x's. And I can get -7x's right here if I take -8x's, and then I have +1x's right there. So I found the factors that work for this -8, and that combine to get me that -7. So now I'm going to actually go ahead and factor the problem right here. By factoring, I want to see what multiplies each of these problems. So I like to focus on this negative row right here. I can see that a negative goes into both of those numbers, as does a 4. So how do I multiply to get to -8x? Well, I have a -4, so if I multiply that by 2, that'll give me -8, and then I need the x. In order to get 2x squared, I got 2x. I'm going to multiply another x to get that x squared. And then x times what gets me 1x? That would just be 1. So my factors on this problem are 2x plus 1, and then x minus 4. Now what I've really done is I've rewritten this original problem. This is the same exact thing as this. Right? This is the same exact thing as this, as long as I have that equals 0 part to it. How do I get this to equal 0? Well, there are 2 x's, so I can take either side and set them equal to 0. I want to do that for both, so I want to take 2x plus 1 and equal it to 0. And then I want to take x minus 4 and equal it to 0. This one's pretty easy. You add 4 on both sides. Boom. X is by itself. One of the x's to solving this problem is 4. If you plug in 4, 4 minus 4 is 0. 0 times anything is 0. We could also plug 4 back into the original, and it would also give us 0. That would take a little bit more work, but you could do it. On this one, we've got a basic algebra problem. We'll go ahead and subtract 1 from both sides. That gives us 2x is equal to -1. Solve for the x by dividing 2. Dividing 2. The x is -1/2. So here are the 2 x's that work. Again, I could plug this back into the original and prove that it works. I could also plug it back into this one. What is 2 times 1/2? That would be 1. There's a negative, so -1 plus +1, that gets us back to our 0. So we have a way to solve this by using factoring. We're going to use the same strategy for this one over here on the right, the problem that's in black. All right, feel free to pause that or take a video of it as I'm about to erase it and give ourselves some more room. So for the problem over here, we have a quadratic which has x squared. We still are going to factor this, and then we're going to try to solve it. Right? So I'm going to go ahead and set up the factor boxes. And I'll put the 6x squared up in this corner. It doesn't matter as long as the -3, the constant, the number with no x's, is on the other corner. 6 times -3 is -18. And it's really -18x squared. Ways to factor -18. I'm going to go ahead and list the factors of 18 first. But these are not -18 yet. I do need a negative. And notice that when I'm trying to get the -7x, the same that I was trying to get here, I need more negatives. So it would not make sense to put the negatives over here. That's going to give me 17 if I add those. That's going to give me 7 if I combine those. That's going to give me 3 if I combine those. So I want to put the negative on the other side. So I have more negatives in the problem. Now I have negative 17. I have negative 7 if I combine that. That's what I'm looking for right there. So if I have 2x's and then minus 9x's, that's going to give me the negative 7x's that I needed. 2x minus 9x is negative 7x. Now I'm going to go ahead and factor. You can start anywhere you want. I always like to focus on the negative part, if there is a part. So this one, there's negatives in this column. This one over here, there's negatives in that row. So in this column, I see a negative that's in common, a negative common factor. I also see a 3 goes into both of those. So how do I get negative 3 to factor to not negative 9x? That would be times a positive 3, and then I would need an x. How do I get to 6x squared? I need to multiply by 2. 3 times 2 is 6. I have 1x. Now I need another x to get that x squared. 2x times what gets you to 2x? That would just be a 1. So we have factored the problem. I'm going to go ahead and write out those factors, which are 3x plus 1, right here on the height, times the base, which is 2x minus 3. You can see that as length times width. But I go back to the original problem right here, which is equal to 0. It's equal to 0. These two problems are exactly the same. If I multiply 3x times 2x, I'm going to get 6x squared, just like the original problem. If I multiply 1 times negative 3, I'm going to get negative 3, just like the original problem. And that tough part was that negative 7x, which we had combined in the boxes there. Cool, all we do to solve this equal to 0 is we take each of them equal to 0. We just go back to some easy algebra. 3x plus 1, how do I get that to equal 0? And 2x minus 3, how do I get that to equal 0? So we're taking it past the step of factoring, and we're going into the step of solving. I'm going to go ahead and subtract 1 from both sides. I get 3x is equal to negative 1. Get x by itself by dividing by 3. And I get x is equal to negative 1/3. I have solved for one of the x's. Here I'm going to go ahead and add 3. Show you some basic algebra. Gets rid of that. I get 2x is equal to 3. Get the x by itself by dividing by 2, dividing by 2. And x is equal to 3/2. So I've solved for both of the x's that work for this x squared for this quadratic problem.